In this video, we'll provide a non-technical introduction to MCP by examining its purpose, structure, the benefits it provides, and the security concerns surrounding it. But before diving into the concept of MCP itself, let's first try to understand why this system was developed in the first place. The problem: limitations of AI models. After the pre-training phase, AI models only have access to the parameterized knowledge they've acquired during training. But information in external sources is constantly changing, and new knowledge is continuously emerging. This creates gaps in the model's knowledge and causes it to become outdated over time. Moreover, because these models are built purely on language, they don't have access to external tools the way we do. To address these shortcomings, to give models access to current information and external tools, OpenAI introduced function calling in June 2023. Function calling: a step forward, but still limited. With this innovation, autonomous AI agents gained greater capabilities by accessing various tools and data sources. However, the design approach for integrating these tools into models resulted in a fragmented system. For each tool, developers had to manually define interfaces, manage authentication, and design execution logic for every individual service. As you can imagine, maintaining and scaling such a system was extremely challenging. Enter MCP, a standardized solution. In November 2024, Anthropic released MCP, the Model Context Protocol. This open protocol enables bidirectional communication between AI models and external resources and tools. Before MCP was released, AI applications accessed external resources through various methods like manual API integration and plugin-based interfaces. This approach increased system complexity and limited scalability. MCP addresses these challenges by offering a standardized protocol that enables seamless and flexible interaction with numerous tools. Thanks to bidirectional communication, tools can now initiate processes and send notifications to the model. Another key benefit of this two-way interaction is that, in addition to enhancing the model's responses through retrieval augmented generation, RAG, by searching vector databases, it also makes it possible to automatically edit and update data. Since its launch, MCP has seen rapid adoption across the industry. In early 2025, OpenAI integrated MCP across their products, and Google DeepMind announced support for the protocol. By December 2025, MCP was donated to the Agentic AI Foundation under the Linux Foundation, signaling its importance as a foundational technology for AI development. MCP architecture: 3 core components. The MCP architecture consists of 3 components working together to enable AI models to access external resources and tools. Understanding how these components interact is crucial to grasping how MCP works. MCP host. The MCP host is the application that users directly interact with, such as Claude Desktop, VS Code, Cursor, or other AI-powered tools. The host is what you see and use. It contains an MCP client component and is responsible for presenting information to users, managing the overall AI experience, and controlling what the AI can do. MCP client. The MCP client is a component that lives inside the MCP host. It's not a separate application. Think of it as a module within the host. The client manages connections to one or more MCP servers, handles the communication protocol, organizes notifications from servers, and enables real-time interaction. In essence, it acts as the bridge that connects the host application with external servers. MCP server. The MCP server provides the actual functionality, the tools, resources, and prompts that AI models need to complete tasks. Servers can run locally on your machine or remotely on third-party infrastructure. They expose capabilities like database access, file system operations, API integrations, web search, and much more. Each server is a self-contained package of functionality that the AI can use. To put it simply, the host is what you see and interact with, the client is the internal bridge component, and the server is what provides the actual capabilities and tools. MCP represents a major step forward in standardizing how AI models interact with external tools and data sources. It offers significant benefits in terms of scalability, flexibility, and developer experience. The standardized protocol eliminates much of the fragmentation that plagued earlier approaches, and its rapid adoption by major players like OpenAI and Google demonstrates its value. However, with great power comes great responsibility. Security is a topic that's recently gained significant attention in the AI space, and MCP is no exception. For comprehensive background on AI security generally, the security challenges are real and serious. Prompt injection, tool poisoning, and other attack vectors pose genuine risks that must be addressed through careful design, robust security measures, and ongoing vigilance. As MCP continues to mature and become more widely deployed, the balance between capability and security will be crucial. Developers, organizations, and users all have a role to play in ensuring that MCP deployments are both powerful and safe. I recommend checking out the International AI Security Report published this month. The future of AI integration with external tools looks promising, but only if we build it responsibly.